Lesson 6.4 on vectors and dot products. So the dot product of two vectors is kind of like a type of multiplication between two vectors. But there's a couple of different types of multiplication that we use. So to be specific, we call this the dot product. So if you have two vectors in component form and you're going to find the dot product between them, you see u dotted with v equals. And what we're going to do is we're going to take the x components of both vectors and multiply them together, and then the y components of both vectors and multiply them together. Then you take those two things and add them. So u1 times v1 plus u2 times v2. That will give you the dot product of two vectors. Now the dot product is going to give you a numerical answer, which when we're dealing with vectors is called a scalar. We're not going to get a vector answer. So some of the products of the dot product, or the properties of the dot product, is that u dotted with v is the same thing as v dotted with u. It doesn't matter the order. And then 0, the 0 vector dotted with another vector is equal to 0. Just like saying anything times 0 is equal to 0. The third property says that u dotted with v plus w means that we would dot vector u with vector w and vector u with vector v. And then we would add those two together. The fourth property says that v dotted with v is equal to the magnitude of v squared. So this is another way that we can find the magnitude of a vector is by doing the dot product of a vector with itself. And then the last one is c multiplied times the dot product of u and v. Now c would be a number or a scalar. So when you multiply a scalar times the dot product, you would only multiply that scalar times one of the vectors, not times both. Next is the angle between two vectors, and it says that the cosine of theta is equal to the dot product of u and v divided by the magnitude of u times the magnitude of v. So if I want to find the angle between those two vectors, I'm going to do this on the right and then take the inverse cosine to find the angle. And then the last thing is orthogonal vectors. Orthogonal is just a fancy word for perpendicular. So when two vectors are perpendicular, they are called orthogonal. The way that we can determine if two vectors are orthogonal is by doing the dot product between those two vectors. As long as the dot product equals 0, then they are orthogonal. So example 1 says to find the dot product of these two vectors. So the first thing we're going to do is write these two vectors in component form. So vector u, 4i minus 2j, is equal to 4, negative 2. And vector v, I minus j, will be the vector 1, negative 1. So now that we have our vectors in component form, we're going to do the dot product of u and v. So u dotted with v is going to equal the vector 4, negative 2 dotted with the vector 1, negative 1. So when I'm doing the dot product, I'm going to multiply the x's. So that's 4 times 1 plus, I'm going to multiply the y's, negative 2 times negative 1. So in the first parenthesis, 4 times 1 is 4. Second parenthesis, negative 2 times negative 1 will be a positive 2. So then 4 plus 2 will equal 6. So the dot product between these two vectors is 6. Okay, number 2 says to find the indicated quantity and state whether the result is a scalar or a vector. So after we do this expression and fill in the vectors, they want us to just state what our answer is. Is it a number or is it a vector? So let's plug our vectors in. So we're going to do parenthesis 3 times vector w, which is 1, negative 2, dotted with vector v, which is negative 3, 4, close parenthesis, times vector u, 2, 2. So kind of think about order of operations here. We're going to start inside the parenthesis, and let's go ahead and distribute the 3 and multiply it times that first vector. So when I do 3 times the vector 1, negative 2, that's going to be the vector 3, negative 6. Everything else is going to stay the same. This vector dotted with negative 3, 4 times the vector 2, 2. So then inside the parenthesis, we're going to do the dot product. So 3 times negative 3 is negative 9. Negative 6 times 4 is negative 24. And then this is still times the vector 2, 2. So in the parenthesis, negative 9 plus negative 24 is negative 33 times the vector 2, 2. So then I would distribute the negative 33 into the vector. So that would give us the vector negative 66, negative 66. And this is a vector. If we had done all of this work and we'd just gotten a number answer, then we would say that that is a scalar. Okay, number 3 says to use the dot product to find the magnitude of u. So we can find the magnitude the same way that we did in section 3, but they want us to use this property that a vector dotted with itself is equal to the magnitude squared. So vector u here is 20, 25. So I'm going to say the magnitude squared equals 20, 25 dotted with 20, 25. So the magnitude squared, we're going to do the dot product. 20 times 20 is 400, plus 25 times 25 is 625. And I add those together, I get 1025. So this is the magnitude squared. I need just the magnitude. So I'm going to take the square root of both, and I get that the magnitude would then be equal to the square root of 1025. Well, let's simplify 1025 and see what it reduces to. So the smallest prime number that goes into 1025 is 5, and it goes in 205 times, and then 5 goes into 205 41 times. 41 is a prime number. Nothing else will go into 41. So I circle my pairs. The pair is going to come out as one of those numbers, and the leftovers are going to stay inside. So this is going to be 5 square root 41. So this is the dot product, or using the dot product to find the magnitude. Okay, number 4 wants us to find the angle between the two vectors. The formula to find the angle between two vectors is cosine theta equals the dot product of u and v divided by the magnitude of u times the magnitude of v. So let's first rewrite our vectors in component form. So vector u is 5, 5, and vector v is negative 6, 6. So I need to find the magnitude of each of these vectors. The magnitude of vector u is going to be the square root of 5 squared plus 5 squared. So that's going to be the square root of 25 plus 25, which is the square root of 50. And then the square root of 50 will reduce and simplify to 5 square root 2. Now for the magnitude of v. So v equals, or the magnitude of v equals the square root of negative 6 squared plus 6 squared. So that's the square root of 36 plus 36, and then the square root of 72. The square root of 72 will simplify to 6 square root 2. So now we're going to take our 4 pieces of information and plug them into our formula. Cosine theta equals u dotted with v divided by the magnitude of u times the magnitude of v. So on the top, when I do the dot product, 5 times negative 6 will be negative 30, and then 5 times 6 is 30. Over, on the bottom, when I do 5 square root of 2 times 6 square root of 2, we do 5 times 6 is 30, and square root of 2 times square root of 2 is just 2. So that's 30 times 2 on the bottom. So we have that the cosine of theta is equal to 0 over 60, which is just 0. When I take the inverse cosine of 0, we get that our angle between these two vectors would be 90 degrees. Okay, number 5 is just like number 4. They just started a little bit differently, and I didn't put one like this in your homework, and I'm not going to put one like the quiz. So we're just going to skip example 5. So on to number 6. It says to find the dot product of u and v. So we're going to use the same formula. Cosine theta equals u dotted with v over the magnitude of u times the magnitude of v. So we're going to plug in everything that we know. Cosine theta, which is 2 pi over 3, equals u dotted with v over the magnitude of u times the magnitude of v, 4 times 10. So you can use your unit circle and find the cosine of 2 pi over 3, or you can type into your calculator, but make sure you're in radian mode, and the cosine of 2 pi over 3 is negative 1/2. Equals u dotted with v over 40. So I'm trying to find the dot product. I want to get u dotted with v by itself. So I'm going to multiply by 40 on both sides. So then u dotted with v is going to equal 40 times negative 1/2, which will be negative 20. So the dot product of u and v is negative 20. Okay, last one wants us to determine whether the vectors are orthogonal, parallel, or neither. So when two vectors are orthogonal, that means they are perpendicular and their dot product is equal to 0. When two vectors are parallel, they are called scalar multiples. That means they are multiples of each other. So if they're not orthogonal and not parallel, then they would be neither of those two. So first we're going to test to see if these two vectors are orthogonal. So we're going to do the dot product of u and v. So that's going to be negative 12 times 1/2 plus 30 times negative 5 over 4. So negative 12 times 1/2 is negative 6 plus 30 times negative 5 over 4 is negative 37.5. Now in order for these to be orthogonal, they're supposed to add to equal 0. Well, obviously these are not going to equal 0, so these two vectors are not orthogonal. So then I want to test to see if they are parallel. So I'm going to take the components of the vectors and divide them to see if they are multiples of each other. So if I do negative 12 divided by 1/2, I want to see is that equal to 30 over negative 5/4. So when you do negative divided by 1/2, or negative 12 divided by 1/2, that's the same as negative 12 times 2, which is negative 24. And then 30 divided by negative 5/4 will be the same thing as 30 times 4 over negative 5. And that's also negative 24. So since these two are equal, that means these vectors are parallel. If I had gotten that they were not orthogonal and not parallel, I would have said neither. Okay, so your worksheet 6.4 is due in class on Friday.